Now, controlling spray nozzles to spray exactly when needed can be problematic. With simple spray nozzles, with simple hydraulic nozzles, the only input variable is the fluid pressure applied to the nozzle. Now, pressure can be varied to increase and decrease flow rate, but it's not very responsive. It's a fairly crude way of controlling flow rate and have a big effect on the other spray properties, which you may not want to alter. So if you increase pressure to increase the flow rate, you're also going to decrease the droplet size. You might change the spray pattern slightly, the spray angle. It's not a very effective way of getting precision control. It can take a lot of fiddling around to get the spray set up correctly if you've only got that one variable to play with. How do we control nozzle, for example, on a coating line where we want to get the exact amount on target to coat something in a regular, repeatable way? So the first thing we can do is we can add a control valve. So adding a shut-off valve near the nozzle can help control the on-off cycle. A basic hydraulic valve is unlikely to offer enough responsiveness for precision spraying. You could get a solenoid valve in there. Even if you've got it very close to the spray nozzle, it's unlikely if you're just controlling that fluid line in there, you're going to get a particularly great responsiveness on there. And it also offers no control over the flow rate. You still only got the pressure to do that. For a basic continual spray line, this is perfectly fine. So you've got a conveyor and you want to continually spray along it. A simple control valve on the spray system that activates when the conveyor turns on. That's perfectly fine. You don't really need precision control there. But if you're doing any kind of stop-start spraying there, a basic valve is unlikely to offer the kind of control that you need for stop-start spraying applications. So the next thing you can do is you can move up to having an air-actuated spray nozzle. Now in this type of system, we have a spring-loaded shut-off valve inside the nozzle itself, and that spring is generally set to being always off. So if there's nothing to overcome the force of the spring, the nozzle is off. And the way we overcome the force of the spring is by using air. So you have an air line in there. This isn't used to atomize the spray or anything like that. It's not an air atomizing nozzle. We'll talk about that in a minute. But the air is simply used to overcome the spring, overcome the valve and get a nozzle to spray. Now air is very responsive. You can hook up a number of these nozzles to an air line, and then you can control the on and off of the air via a solenoid valve. Single valve can control multiple nozzles. Because air moves very, very quickly, because it's very, very responsive, far more so than liquid, you can actually achieve some fairly impressive on-off cycle rates with this type of control system. So hooked up to a solenoid valve, you can get nozzles to cycle on and off up to about 3 times per second. This is getting quite precise. So for those conveyor type coating applications where you want to start spraying and stop spraying when the target's underneath the spray nozzle, this is normally perfectly responsive enough. This air actuation offers enough control there to get that precision on and off cycling. But again, we've got no particular control over the actual fluid spray properties here other than by varying the fluid pressure. So that moves us on to air atomizing nozzles. Now by using air atomizing nozzles, we're adding another variable into the spray mix. We have 2 fluids coming into the spray nozzle. We've got the liquid we're trying to spray and the air in there as well. And that interplay between the air and fluid pressure can give us some quite dramatic variations in the types of spray that we can achieve from a single nozzle setup. So we can also use the air in there to actuate the nozzles in exactly the same way as the air actuated nozzles we discussed a minute ago. So you can get those sort of 3 times a second on-off cycles with air atomizers. But what you can also do is you can get a big variation in flow rates, and you've got a certain degree of control over the level of atomization as well, because you've got those 2 variables, you've got the air and the fluid, and if you know what you're doing, you can get a lot of different spray types out of a single nozzle setup. You've got a lot more control over that. However, that control can be quite tricky to set up. You've got to know what you're doing, and you've got to have very, very precise control over the fluid and the air pressure there in order to achieve what you want. So finally, we can move on to talking about electronically actuated nozzles. Now these kind of give the ultimate level of control, because with this type of nozzle, we have a rapid response solenoid valve built into the nozzle body itself. And these will be linked to an electronic control system. Not using any air in there, so we are losing that second variable, but we're introducing another set of variables because of the solenoid valve is integrated directly into the nozzle. This allows up to 150 on-off cycles per second. And when we can achieve that level of control, we can do a process called pulse width modulation. And this allows us to rapidly pulse the nozzle on and off so fast that it doesn't really make any difference to what the target sees. So you're still getting an even distribution of spray, even though it's going on and off. But in this way, we can actually control the flow rate without affecting any of the other spray properties. So we're not going to affect the spray angle, we're not actually changing the fluid pressure at all, so we're getting the same spray angle, the same drop size out of that nozzle, but we're just reducing the flow rate by actually having the nozzle off, say, half the time, but we're still getting an even coating there. So hooked up to a suitable control system, this can give an incredible degree of control over the flow rates that we can get out of a single nozzle setup. So we can vary the flow rate by pulse width modulation, we can vary the frequency of the modulation to change the coating uniformity. We can set spray cycle times, we can set a delay between the trigger and the spraying, control up to 20 different spray zones, each to an individual trigger. These are all controllable from a simple touch panel interface. So this kind of gives the ultimate degree of control even over very, very complex automated spray setups. So this can be achieved with multiple nozzles operating from multiple sensors, perhaps spraying on different spray cycles depending on what you're looking to achieve.